In the last video, we saw how we can use LangChain to implement a simple LLM model in our code. So what we did was we added the API key for the Gemini in our env file, loaded that env file in this code, installed the LangChain package, and then made a simple prompt with a placeholder question. We used the model Gemini 2.0 Flash. We made a simple string output parser, made our own chain with the output parser, LLM, and the prompt. And then we use the chain using the invoke method. So what this does is it just sends our own prompt to this model that is hosted on the Google's servers, gets the response and makes it into a strings and then prints it to the screen. So if we run this right now, we can see that it says that the capital of France is Paris. So great. But do you see a problem with this approach? So for example, what if you don't just want this to be able to answer general questions? Let us say that you own a hotel and you are trying to build a chatbot for your own hotel. So you want your customers to be able to ask questions like, what is the price of a room for one night? What is the cost of some item on the menu? And be able to place orders for home delivery, etc. With our current implementation, when we ask this some general question like what is the capital of France, or anything like what is the color of a mango, etc., it gives a decent answer. But what if we ask something more like what is the vada pav? Let's see what it says. So it does give you an answer, but it gives you a very generic answer saying that it depends on where you live, and it might be 15 to 20 rupees, and it can even be more than 50 rupees if you go in a very expensive restaurant or something. But this is not what we want, right? If we own a hotel and we want to make a chatbot for our own hotel, we would want it to be able to give the price of the vada pav that we are selling it at and not some generic answer. So what do you think can be done? So one simple solution might be just add all the information in the prompt, right? We might say that you helpful assistant that answers about the questions about our hotel based on the below data. And let us say hotel name, location, menu. And for the menu, we have please answer the questions on the above data. Yeah, so now again, if we just run this same code, it clearly says that the price of the vada pav is rupees 10. So this is a good enough approach when you have very little data. Let's say over here we just have 5 to 10 lines of data, right? But what if there is a lot of data? Instead of a hotel app, maybe you're making a program that can answer questions based on research papers. Maybe you can ask the app about something and it would go through a lot of research papers and give you the answer. Or maybe even if your hotel data was a lot and not just 3 4 lines, right, it would not fit into it would ruin the token limit for your prompt, because if you write a lot of info in the prompt itself, there will be very less tokens left for the actual question. What So another approach would be we can use RAG. So what is RAG? RAG is Retrieval Augmented Generation. So in this, what we do is when we get a query from a user, instead of giving it directly to the LLM, let us say we have a lot of data about our hotel in some documents, right? About our hotel. And we want the LLM to have access to this data as well instead of all the just generic data. Because when the LLM was trained, it was trained on general data that was publicly available on the internet. So if we just send the query to the LLM, it won't be able to answer questions that are based particularly on your business. So what we want to do is we want to send your query along with this context to the model and then generate the response. But it's not that simple, right? As you can guess, we can't just send all this text to the LLM if there is a lot of text. So what we do instead is we first will convert this text into embeddings, into vectors, right? So what we will do, we will use some kind of embeddings and then first convert this. So we'll use embeddings to convert this data into vectors. So instead of storing our information in plain text, we'll convert this into vectors. So what vectors are it's just they are just a list of a lot of numbers, a very long list of numbers that we can create using any embedding method. So different type of embedding methods are a topic for their own video. But for now, just assume that we convert these plain text documents into long list of numbers and then store that in some database. So these type of databases which store a lot of vectors are called vector stores. So what we do is we create embeddings from our context and we store into a vector store. Then what we do is whenever user gives us a query, we have a retriever over here in the middle. So instead of just giving this query directly to the LLM, what we do is we give this query to the retriever, and this retriever will query the vector store. And what it will do is it will receive some documents, some vectors that match the query the closest. So what do you mean by matching the query? So what we do is we take the query and convert the query also to a vector using the same embedding that we use to convert the documents into the vectors. So let us say the guy asked, what is the price of a vada pav? Right. So this is the query. So what we will do is we will convert this query also to a vector using a embedding method. So convert the query to a vector and then we will try to search the vector store to find a vector that is very closely matching with the query vector. So how do you find vectors that are closely matching? So one way is using the cosine similarity. So that is the dot product. So whenever you find the dot product of two vectors, higher the dot product, the more the vectors are matching with each other. So let us say we perform the vector search on this vector store and then we got a vector that is the embedding of, let us say, something like uh, it could be any vector which with some numbers which represents the document. The cost of a vada pav is 10 rupees. So this vector goes back to the retriever and the retriever then converts the embeddings again to the plain text. So now the retriever has the query in the plain text. It also has the context in the plain text. So what it will do is now it will pass the query and the context both to the LLM and then get the response from the LLM to the user. So now the LLM might respond something like the price of the vada pav is rupees 10 in our hotel. Since the LLM now knows what the price of the vada pav is. So obviously this also has a lot of complications and this is not the only way to perform RAG. Maybe you want to search the internet with your query and want the LLM to be able to have access to internet as well. Then what you can do is just get the query do a simple internet search with the query and on a search engine like Google, Bing, anything, and then give the top 5 web pages that it gets in the HTML format again to the LLM. So there are a lot of ways you can add context with your query so that the LLM is able to answer questions based on your business data, which it was not trained on. So this is the basic idea of how RAG works. So now let's go ahead and try to implement this in code. So first of all, you will have to install a simple vector store. So for our example today, we are going to use a simple vector store called FAISS, FAISS. It was made by Facebook, and it is just a simple vector store that is easy to use for simple demonstrations. Otherwise, there are a lot of vector stores like Pinecone, etc., which can be used in larger projects. So first, let's go ahead and install that. So we'll install FAISS CPU, which there is also a GPU implementation, but since our data is very small, the CPU one will do. And till the package is getting installed, the library will see that we have created a text file, a txt file with the info about our hotel, the info that we want our chatbot to have access to. So we just added some generic lines like hotel opens between 8 and 11. We serve vada pav, chai and biscuit, and the prices of all the different things. And we only have veg options, etc. And okay, so this was also installed. This was already satisfied, but if not, it would install it for you. So now let's close this. Okay. So first we'll have to go ahead and generate the embeddings from the txt file. So to do that, we'll have to import. So we imported a document. We also imported the FAISS vector store and also the embeddings. So for the embeddings, we are going to use the Google Generative AI embedding since we are also using the Gemini model. Then let's go ahead and read the file. Okay, so now that we have read the file, you might be thinking that since we want to convert the text into embeddings, we can't just also convert the whole text into a single vector, right? There must be a way that we have to split the text. So there are multiple ways. We might want to make a single line into a single vector. So that is one option. But what if there are not lines but a one large paragraph? So the most basic option might be we can use a recursive text splitter, recursive character splitter, and divide the text into chunks of a certain size and then use those chunks to generate the vectors. So we'll also import the recursive character text splitter. Then we'll make a splitter. Let's make the chunk size a little smaller since our text is very small anyways. And then let's make the chunks. Chunks equals to splitter dot split text the hotel info. And then we have to make the documents. So docs equals to document. So this is what we imported from LangChain. Page content is chunk for chunk in chunks. So now we have the docs ready. EMB. Let's also make the embeddings, and you don't have to give the model. Then we create the vector store. So vector store equals to fastest dot from documents. We give it the documents and the embeddings. And then let's just save this vectors. So vector store, save local hotel vector store. So now when we run this, so this is in documents and not document loaders. So you just have to import documents from LangChain core. And you also need to install LangChain community as well to be able to access the vector stores. So now let's run this again. This you import from LangChain Google Gen AI and not from the LangChain core. And another simple typo, there is a S in here. And you also have to give the model for this. So we'll use the 001 embeddings model. So as we can see, it generated a directory with the name hotel vector stores, which has the metadata file and the actual embeddings. So now we can load this in our code and then create a RAG based LLM chain. So for that, let's quickly go here. So for the RAG, we are going to use the same chat Google Generative AI model, and from the LangChain, we are going to use a retrieval QA chain. So retrieval QA chain is specifically used when we create a retriever from a vector store and then we want to ask the LLM questions with the context that are retrieved from the vector store. So then let's go ahead and load our vector store. We'll also have to import the embeddings and the vector store here, the FAISS vector. So then what we do is we just create the same embeddings from here and vector store equals FAISS.load local. We give it the name of the directory and the embeddings that we used while generating the vector store. So now that we have the vector store, let's go ahead and make a chatbot which we create the same as before. Then what we do is go ahead and we make a retriever. So retriever is nothing but what it does is the retriever, we can give it to a retriever chain and then it will do the querying for us. When it gets the user's prompt, it will query the vector store with that prompt and get us the top two documents that are matching with the prompt. And this is actually optional. So if we don't give this, it's still okay. Then we have the QA chain equals to retriever QA from chain type. Let's give the LLM. Let's not give the chain type. The retriever will be this retriever and return source documents is true. So what this does is it also gives us what documents it used in the context. Now let's invoke this. We can give what is the price of the vada pav to our QA chain. Then we print the result and we also print the source documents. So let's see how this performs. I guess again, this is wrong. Okay, so since this stores the vectors in a .pickle file and .pickle files are dangerous and they can have malicious code in them as well. So what we have to do is we'll have to allow dangerous deserialization to true. Otherwise, it will not allow for the loading of the vector store. See, so now as you can see, it gave us the correct answer. The cost of the vada pav is 10 and source document, the cost, it got this document from the source. So so even though it had a lot of other info, it still only got this line since it uses a cosine similarity search to search through all the documents and only get only get the document that are the most useful. So now what we'll do is, let's try asking it some other question. Maybe, so yeah, it says we only have veg options. So it gave the correct answer, and this is the source documents that it retrieved. So as you can see, it is not very difficult to create your own vector store and make the chatbot be able to answer data from your own business solutions. So this is one way to go about making the LLMs have context about your business or about the data that they were not trained on. Another way you can solve the problem of giving the context about your business solutions or your business data to the LLM models, apart from RAG, is fine tuning, where you actually train the LLM model on your data and modify the weights inside the model itself. But that requires a lot more computing power and it's also much more costlier. So maybe we'll learn about that in a future video. But that's all for today. Thanks for watching.